posterity.
Yes.
Okay, it's doing something.
Okay, there you go.
Yep. I heard it. Recording in progress. All right, Mike. All yours.
Okay.
Sorry, Mike.
Good evening, everyone. It's the 16th of December, the last one before Christmas. And tonight we have Dale Brown and John Sprakes who will present to us. And they're doing a presentation on early systems lifecycle activities. Systems engineering is missing. So this will be an exciting bit because if you don't start your project properly or correctly, or with good systems engineering, it could go astray and lead to problems. But the presenters are Dale Brown from Hatch LTK. Now, Dale joined Hatch in 2019 as Director of Systems Engineering. He brings 37 plus years of transit and rail experience. He is a licensed professional engineer with extensive R&D, design, management, and business development experience. Dale has traveled to 47 countries and has further been awarded a number of design patents in rail sector for rolling stock control systems. Dale has required experience in digital electronics design, software development, and embedded control of specialty equipment, mining, heavy construction, military, and rail vehicles throughout the US, Canada, South America, and Europe. Dale is co-chair of the INCOSE Transportation Working Group and is co-chair of the INCOSE Configuration Management Working Group. Dale is also the relationship manager for the APTA INCOSE Cooperative Agreement and is the current chair of the APTA Systems Engineering Subcommittee. Now, John Sprakes is works for Stantec. John is currently a senior systems engineer at Stantec Canada. He began his systems engineering career as an air-to-air refueling systems performance engineer for Flight Refueling Limited, and then as a fuel systems engineer for the A350XWB program, and as a fuel system research and development engineer for Airbus UK. After his time in aerospace, John joined London Underground as a systems engineer for the four-line moderation program from 2007 to 2016. John has emigrated to Canada in 2016, where he worked for SNC-Lavalin as manager systems integration, working large Canadian P3 LRT projects until 2019. John specializes in program and project level systems engineering and is experienced in delivering systems engineering across the full system life cycles. Recently, John is now involved in leading the development and deployment model-based systems engineering using MBSE using SML on transportation projects. So with all that said, John and Dale, take it away.
Great. Thanks, Mike. And welcome everybody. And we'll hopefully stimulate your minds with some of this stuff. So you're going to see this slide. It's going to appear several times, not quite so subliminally, more like hitting you with a brick. If you walk away from nothing else, with nothing else today from the presentation, this is kind of what we want you to remember is just think about the first 15% of the project spend. Spend it wisely because it'll really pay a lot of dividends. So that's our main takeaway for you from today. So we're going to kick it off with that. And having said that, I'm going to just turn it right over. John and I will be going back and forth through the slide deck, talking about different slides. So go ahead, John.
Okay. Good afternoon, good evening, good morning, wherever you are. So the first thing is, as Dale said, is, the part of this, our main kind of takeaway from this is to really think about the first part of the project or program and really understanding, where we can see improvements that can be made in that area that will allow projects to be more successful. So if you go on to the next slide, please. So what is the first 15%? So just as an approximation, you can almost say it's up to contract award in the middle of concept design as what's regarded as the first 15%. Where this came from, Airbus did a lot of work. And I remember when I was an engineer there, I sat in a lot of training courses, and they really emphasized this first part of the project. They looked at all the aircrafts that we were building, and they looked at the 80 programs and things like that. And they really said to us, we figured out that if we don't get this right here, it really causes problems downstream and towards the end. And it actually affects 85% of our realized product or system at the end. So, what we got here, and it was far away, Dale. So you got business plans, codes, regulations, the con ops, concept of maintenance, stakeholder requirements, civils and systems requirements in this phase, reference designs, your contract requirements, and here is kind of your design options. So everything in this area here, obviously there's other bits, risks and all those other things that need to be factored in as well. But from a systems engineering perspective, those are kind of all the key bits that we're looking at in this first 15%. And as we go through this presentation, you will see where things haven't gone right and what the impact's been, where things have gone really well and projects have been successful. So one of the feedbacks you get from talking to all the systems engineers and even all the other engineers is that there's always saying, hey, I wish we'd spend a bit more time in this first part of the project to really get the quality a bit higher, because we get to RFP and we get to award, and then suddenly people are challenging the quality of the contract and everything else like that. So next slide, please. So here's some things. You can get all this off the internet. So I did an internet search, looked at all these things, and basically, the contracts have asked from a system engineering perspective, ISO 15288, Senelec, various Ontario projects, BC, Alberta, everything across the last 10 years or so. Some of them haven't been too successful, cost overruns, goals and objectives not met, schedule delays, design milestones have been delayed, objectives, things like that. So there's a common theme running through here. And some of the causes are, requirements not fully met or complete. There's SI issues, lack of V&V, safety cases, operational restrictions involved, scope gaps, requirements issues. And the running thing, there seems to be everything around requirements. Now, is that something that happens, from a contractor side, or is this something that's happens, pre-contract? And it's really interesting that we're starting to see that the requirements comes up every time. The quality of requirements, or there's too many requirements, or there's not enough requirements. So that's an interesting thing that's come back. So even though we've asked for all these standards like ISO 15288 and Senelec, we are still suffering problems by either not following the processes, or these processes might not be fully transferable to what we do. We're only using bits of the standard. Maybe we're just not using any of the standard because of time pressures, schedule pressure, cost pressures, and things like that. But we know that 50128 is a successful standard. However, it just seems that requirements and things start coming up, which is kind of like the bread and butter and the skeleton of 15288. Next one. So what can SE provide? Improves the chances of successfully achieving the project goals and objectives while ensuring scheduled performance and reducing risk cost overruns when delivered properly. So what are the key challenges? I've tried to dwindle them down to three kind of takeaways. One is increased technology demands. We're seeing a lot more connected systems now, a lot more open architectures. We've got a lot more systems talking to each other, relying on others for information, across everything. Whereas before, I think, you could say 10, 15, 20 years ago, there were a lot more closed systems. You bought a separate system, you could put a separate workstation to a monitor and it did its things. Like SCADA was power. Now, things like SCADA monitors everything. And, there's a lot more, like I said, cross information going on. So, and as we become more advanced, as we're seeing Internet of Things arriving, you've got automated vehicles, cars and things like those sort of things happening. You've got vehicle to infrastructure, vehicle to vehicle, vehicle to satellites. So infrastructure engineering is going to have a lot more embedded systems in it that need to be communicating with a lot more things. System-oriented standards, obviously standards get put in there. I think anyone who's on this call here has probably seen rafts of standards and codes and regulations put in. And and the difficulty is that when people ask for this, certainly on the client side, worked on this client side, we expect something to come back that's going to align to them. But often what's happened is that there's always a disconnect between project management and the system engineering. So project management comes, hey, they've asked for this standard. We need you to go away and do something. Great. You just do what you need to do in the systems and off you go. And so we'll talk about that as one of the things there. Obviously, the arrival of Senelec now in North America. This is around RAMs and safety. There's a lot more rigor going on there. Making sure that all the functions and features of the systems have been tested and are going to be available and reliable and when they're needed. And then the other one is more effective workflows. I think clients are looking now for people to react quicker to change. They know technology's out there. You've got BIM, you've got system architecture tools, you've got doors, all those type of things. They're saying, well, we've got all this technology. If we change a scope, you should be able to give us the impact a lot quicker. And that puts a lot of pressure on, getting the right tool sets, getting the right engineers and people who can use that to able to react to those changes quicker. And then schedule demands as well. Key obstacles that are facing systems engineering. First point would be lack of SE understanding. You find out system engineering is fairly localized. It's like all the system engineers know what they're talking about, but then as you go out to a wider sphere, it sort of starts getting less and less and less, and in organizations. Projects and cultures, resistance to change, the old way is the best way. I think everyone's probably heard that term a few times. And then obviously SE image problems, whereas SEs, we've got responsibility to communicate as well. And, we've got to get across what we're trying to say, this is what system engineering, this is what its benefits are, this is where we can help you. And sometimes it gets lost in translation. So challenges to SE adoption, obviously there's a knowledge gap. SE is not seen as a core competency like project management. If you talk to people about project management, they'll know, yeah, PMI, everything is fine, that's great. But system engineering, even though we have a lot of overlap with project management, is still not seen in that framework and given that kind of same level of, I can't think of the word, is the same level of like respect as saying, yeah, that's what, system engineering complements that. Project managers often come from non-SE backgrounds, so not aware of SE. So, we have to kind of manage that knowledge gap. Strategy issues. SE is not considered in the early developments project. People have got everything sorted out. I've been on a few things where, oh, by the way, we need you to go do some system engineering, and most of the RFP's been set. You just got to sort out the requirements for us. We're saying, oh, what about trade-offs and all those types of things. SE is considered low-level discipline, only applied if required by contracts. If the contract asks for it, system engineering is in. If the contract doesn't ask for it, no one does it. Simple. SE practice, little or no budget for SE in early project phases. And then obviously inexperienced junior engineers assigned SE roles. I think, sometimes I've seen that, hey, look, can you go and do requirements? You give them to an EIT, you let them loose on doors databases and things like that. And, those are some of the things, maybe around lack of awareness of what SE is and what level of experience you need to, because SE, even though it's getting a lot more recognition in universities, it's still something you have to practice to become good at. Right? Over to you, Del.
Oh, thanks, John. And so as John said, projects are specifying conformance to the standards. Sometimes just, magically putting in phrases like the supplier shall, conform to the processes in ISO 15288. Well, if the prime on the project is a large constructor, civil constructor, they're going to look at that and and sort of maybe look at one of their subs and say, yeah, can you guys go take care of this? We don't know what that is. So that's kind of the issue with the way things are set up now. And you know, just the fact that they're putting it down on paper and asking for it doesn't mean that it's being applied. And this is similar to what John was just saying. You know, we've got some situations where it may have been asked for on paper, but somehow you know, they didn't get the heights of the station platforms and bridges you know, correctly. So that's a little bit embarrassing. SNCF, of course, this is probably extremely famous, where the width for on the regional platforms, the trains wouldn't squeeze through nicely. So that's pretty embarrassing. And then this is not the project I'm currently working on, just for anybody who's on the call from that project. So I'm going to take that disclaimer right now. However, this is another very large project, not quite as large. And the requirements in the RFP were incredibly poor quality. There's no, you know, it was like 80% of them did not comply with the basic quality standard 29148. QA, by virtue of what I just said above, was kind of missing in action, but also later on in the project, you could tell there was really no engineering process QA happening, especially, unfortunately, with change control and defect tracking. There's an awful lot of design statements in the requirements. So everybody's a frustrated designer. So when they're trying to write system requirements, they end up, you know, gee, I really want to be on the design team, so I'm just going to tell them how to do it, even if it's a COTS train control system. The RM practitioners, as John just said in his previous slide there, weren't really competent with the processes. The setup was inexpertly managed. That's being generous. And then they were putting, you know, the first, it's not a, you know, we try to keep away from branding stuff, but, you know, we've already mentioned DOORS, and it's pretty popular. The first word, of course, in the acronym DOORS is dynamic. So this tool was being applied in a static fashion using disks and sort of sneaker net approach. Not a great way. It's an excellent way to lose configuration management and end up with some chaos between, you know, multiple versions of the truth. And really what ended up in this project is it just degenerated into a tick box. So it actually had a negative return on investment at the end, because now everybody's scrambling, trying to figure out how do we close out this requirements mess that we've got with 25,000 requirements for a COTS, you know, sort of design build scenario. So sort of summarizing that, you know, there's a lot of poor requirements. The tool was set up very poorly, and sometimes you end up in projects where both of those are happening. It's not good. But there's this weird false logic that comes out, where, you know, the conclusion that I've heard many people make is, well, you know, this isn't the aircraft industry. All this stuff is way too complex for rail and transit. And, you know, they're basically making that statement on, unfortunately, as a result of some of the failure modes that are described in some of these projects that we're showing here. It's not true. It's, you know, it's how it's deployed is what makes it work or not. So, and as an example, we're going to just do a real quick 5Y, except this is more than 5, so I call it multi-Y. So the bad news, projects have modes of failures. Like any system, each failure needs to be analyzed, you know, to figure out what's going wrong. So if we look at a notional project here, this isn't an actual project, although the concept came from the real project. You've got some sort of functionality missing. So you're saying, okay, that makes it a failed project. Well, why did that happen? Well, there were system requirements missing. Well, why were the system requirements missing? Because the stakeholder requirements were missing. Well, why were those missing? There was no funding to do stakeholder requirements. Well, why was there no funding? Because the need wasn't understood. So it basically, and this is what drilled all the way back down into the early life cycle activities. The good news is that the analysis of these project failures has been done, and we're going to reference some of those failure studies later on in this presentation. John's already put a few of them up, and I've put a couple up too, but there's actually been some analysis and some reports that point to the root cause of a lot of these rail and transit project failures. So in accompaniment with that, there are some hidden costs. We used to call them in manufacturing, we call them hidden factories, activities that consume resources and people, like real money, and they're not really accounted for or monitored or recorded. So, and a lot of them you'll see in a second are related to those missing early activities that we talked about. So a lot of the sort of assumptions are that, all the cost overruns are sort of in line with those top five. And there are a number of them that are, things like absenteeism, low productivity of staff, high labor rates, maybe a very poor job estimating, although the root cause for that is related to what's going to appear below the iceberg. So below the iceberg are the actual root cause cost drivers. So you've got underdeveloped scopes. I'm not going to read them all because it's a separate presentation all of its own. But it really gets back to not doing your homework at the front end of the project. So here's one of those reports I was talking about earlier. This is from GIP Journals. And these are the things they found. There's about 10 bullets here, so I'll go through them quick. The audit chain of custody, lack of data collection at the beginning of the project. There was missing survey data before the design started. Scope changes not tracked and controlled. There was delays in approvals and decision-making. Configuration management is either ad hoc or missing. There's delays due to misalignments between the owners and the suppliers, AKA requirements, excessive rework due to errors in requirements. Compliance delays, again, it all ties back to requirements, and lack of communication and coordination among stakeholders, which can also be, loosely related to requirements. So the summary of all that is what they said in their report is they're not, these projects are not deploying the best practices, and they're not getting the SE enabling processes up and running. And one of those, of course, is configuration management. So that's one report. This is more global, and I think a lot of you have heard of this before. So, and they do this every year, the Stantec group, they go out and they monitor about 50,000 projects. So it's pretty good, for those of you that are into statistical process control, that's a pretty decent sample size. So 84% of the projects either partially or completely fail. Just on a planetary resources note, that's kind of sad for society, but we'll try to see what we can do to fix some of that. So that's a pretty low success rate. It's a lot of wasted resources. So 53 of them were over cost, and 31 were really in trouble because they were either canceled or abandoned. So the top 5 reasons that Stantec Group came up with in 2019, and I think it's similar this year, there's the word again, incomplete requirements, changing requirements, lack of user input, which is related to, the whole point of doing systems engineering, lack of executive support, and technical incompetence, which we've also mentioned in the previous bits. So this is kind of getting back to that 15. You're going to keep seeing that 15% thing come up, and it's related. This isn't actually from a particular study, but it is the defense. What is it? The Defense University in 1993 came up with Acquisition University. Came up with these numbers, and really the one to remember is that by the time you spent, you've actually burned through 15 to 20% of the accrued cost. 80% of the life cycle cost is kind of etched in stone. You've only got like 20% opportunity to actually do anything, and that often happens sort of right at final design. So that's, again, early life cycle activities are controlling the life cycle cost. So for folks that are interested in asset management and controlling the life cycle cost of an asset, again, that first 15% is really important. So we'll just do a real quick recap. I mean, there's different life cycles. INCOSE has a very nice selection of them in figure 3.3 in the handbook. You can kind of compare and see where yours fits in. The one at the top, though, is pretty good, pretty basic: concept stage, development, production. Then you use the thing, then you support it, and then eventually you either rehab it or retire it, or and replace it. There's various levels of sort of granularity you can go to in your life cycle, and a common theme throughout them is there's these gates here, and I don't know if you can see my cursor moving around, but so for, there's a system requirements review gate perhaps, and there's a factory automation test review gate, and there's a systems integration review gate, that sort of thing. So we have these review gates that hopefully provide a bit of control and definitely some process control on the whole thing. Again, pointing to the early life cycle activities, you'll see, and this is again right out of the INCOSE handbook, or yeah, this is actually out of the ISO standard 24748. And it shows, all this activity is happening in that early stage. And that's a majority of, of project activities that get kicked off. But what budget was allocated for those, and how much SE is going on in all of those early stages? That's usually before NTP. So John's earlier slide kind of showed the early life cycle phases, and this is where we're getting into a bit of solution space. What do we intend to do about all this after we're kind of moaning about the projects that aren't doing so well? So we're proposing to split these into sort of a business planning, a project planning, a procurement, and a mobilization phase. So these early life cycle phases where you do the agency goals and business planning, and you're setting those, those are the little phrases that appear on the agency website. What is it we're going to do for this year or for the next 5 years? And you tie that in with the state goals or regional or even national transit goals. You put together business cases and you start doing your capital planning. Once you have candidate projects, you need to do all the usual culprits here. You need a charter, you need a work breakdown structure. Stakeholder plan is often not well done or poorly done or completely overlooked. And then you need to actually design the project organization up front. Don't let it just happen. Don't give it to consultants to throw one together, because it'll all just get political. You need to think about a balanced project organization design up front. And then you get into procurement, actual procurement, and again, design the procurement package. Don't just let it happen. Don't just do the same thing you did for the last 15 projects and expect a different result. So that's something that we want to work with in the APTA SE subcommittee. We want to work with the procurement subcommittee and start having those conversations with legal and procurement departments to see what we can do better, how we can make some changes in that area and put a better bid spec package together and do a better job at evaluation. So that's the procurement bits. And then mobilization, how do you start up the project? You don't just assume that all the tools are in a very complex requirements management tool or architecture development tool isn't necessarily just, it's not like plugging in Word or Excel. And then you need training. Hopefully you've done some ConOps work. Hopefully you kind of did that as you're putting the bid spec package together or before then, and some level of stakeholder requirements. So that's kind of what we're looking at for the front end, and where you would hopefully wisely spend your 15%. And then gates, just like in the rest of the milestone, you need some control gates, because if in the business planning stage at gate 1, whatever you want to call it, you have to have off ramps. You have to decide, okay, we're really not going to, promote this project for consideration in the capital planning budget for the year, whatever, 2022, or we might push it back to 2025. That's just one example of a gate that needs to be, respected. And that is a problem that we've noted here. One of the root causes is we need to be more disciplined, and we really need to respect gate processes. And that doesn't change for these early phases. So we've sort of summarized some of these earlier, but lack of ConOps, we've got project goals are not fully defined, timescales to set up these four, these 4 phases are very compressed, and there may not be much budget for it, because it's going to be, well, it's just an RFP. We'll just cut and paste it like we did the last 15 RFPs, which results in low quality when you do that. And again, this is right out of the INCOSE handbook. And there's a very nice little chapter or paragraph here that I'd never noticed before until I was doing this PowerPoint, and I've read the handbook so many times. And, really, they're just saying projects are driven by eager champions who just want to get on with it. And there's a temptation to cut short these early stages, like the concept stage. So they'll use, exaggerated projections to start developing without really understanding the challenges. And there's been a lot of commissions that review failed projects and systems, and they've identified that the superficial work done in the concept stage is a major root cause of project failure. Because here's where the money starts flowing, big money at CDR, bigger money at FDR. There's a lot of pressure to get things moving. So having said all that, a lot of the infrastructure projects effectively start here because that's where the money starts flowing. And this all this other, the preliminary stuff gets compressed into just a few months. And the characteristics are, the teams are mobilized, but I will use, that org chart kind of worked okay on the last project, so we'll just use it. We're not going to put a lot of thought into it. Then you get this crazy thing where at NTP plus 30, you get a truckload of, or at NTP plus 60 sometimes, you get all these plans that come through from the supplier, and the return on investment of analyzing those plans, well, that's why we called it shelfware, because it really is a very low return on investment. And then, of course, the system requirements and the architecture thinking, and sometimes even the systems integration thinking, there was no real budget for it, and they get left in the dust because the design work, as we showed in the previous slide, the 30, 60, 90, the design work pressure is immense. The other thing is that things like the RM tool, the configuration management tool, the document control processes, they're all kind of assumed to be operational because, of course, everybody has a good document control system and you can always find things. I haven't been on a project where that's been true yet. So hopefully we can make some changes there. So this is again talking about the gate process, and we're making a pretty dramatic statement here that projects are effectively doomed to failure years before NTP, depending on how they were planned and set up. So, we're positing that project failure is locked in during these early stages, and also that the gates are not rigorously enforced, because if they were, the project might not ever kick off, or it might get a restart, a reboot, before it even gets to where the RFP hits the street. So we have to challenge this, this way of doing things. If you don't change anything, you really can't expect a different result. So the current observations, I'll turn this back over to John.
Yeah, so thank you for that, Dale. So here's some of the things that are actually being experienced today and feedback from within the industry. So next point, please. So RFP contracts underwent major revisions in concept design due to misscope. So large variation orders hit, in the first 6 months of NTP, and, things were going right. Well, what's going on? Non-acceptance of SE plans and requirements, plans only accepted after 2 years by the client. There was I've heard some experience where, there was just a lot of differences between the contractor and the owner's engineer about exactly what level of system engineering needs to be deployed and be done. So, we're not going to do too much because it's going to cripple us, or you're not doing enough, sort of thing. Next one, 1,000 new requirements were identified in project T&C phase, 18-month project delay and due to rework. I mean, as they were doing T&C, things just started dropping out. Like, well, we've got the design, and then when we've started testing, we've realized that things were missing, defects were occurring, tests were failing, and when all the root cause analysis went back, the requirements just kept popping out. So, well, this wasn't designed, this wasn't done. Oh, we did it to the contract requirement, but the contract requirement was vague. So, sometimes you don't stand a chance if the contract requirement is vague and loose, because let's face it, you've got lots of lawyers who like shall statements. They're trying to cover all their bases, but the vaguer the statements get, the more loosely interpreted it gets as well. Project acceptance delayed, compliance evidence requirements met in the concept design phase was missing or not captured. So early on, they were claiming that, yeah, we've met these contract requirements, but people couldn't go back and demonstrate they actually did it, because by that point, towards the end of the project, 6-7 years later, that's in the rear view mirror as far as most people are concerned. Safety assurance case rejected, PHAs not being undertaken during concept design. In some degrees, I think preliminary hazard analysis or hazard analysis has to happen during, certainly during the actual RFP stage, if you're creating the RFP, just to understand that your requirements are actually capturing that. And sometimes that's all just passed straight over to let the contractors do. Okay, over you, Deb.
Oh, thanks, John. Yeah, so this is kind of, I think everybody's seen this curve, so I won't spend a lot of time on it. And this number 200 I've actually seen a project where that number was actually 1,000 if you have to spend the money in operations or maintenance mode or phase, as opposed to in the spec or even the pre-specification phase. So the Meta Group did another study, and they're directly attributing poor requirements, gathering, analysis, and management to 68% of the project failures. And when that happens, like John was just saying, and again, that 200 is a conservative number because it can be 1,000. So if you've got something that might have cost you $10,000 or $15,000, for a couple of engineers talking back and forth to solve early on, multiply that times 1,000, and it starts to become real money. More than 40% of the development budget can be soon by poor requirements. That should get folks' attention. So where are we at? Oh yeah, and this again, I think sometimes the handbook and the standard are both kind of underutilized resources. So I tried to pull a lot of stuff from both the handbook and the standard in, and this is right out of it, and it's perfect because you've got basically. Wally being told, hey, we don't have time for no requirements. We gotta, we gotta get busy. So it tied in perfectly with what we're saying above. I think it's the only Dilbert in the whole handbook. So yeah, but what they're really saying is there's very strong pressure from PMO because they're rewarded differently. They're rewarded to show progress through the project control gates. And then on the supplier side, the supplier is also rewarded differently. They're rewarded by cash. They want the cash to be flowing. So same thing. So when you've got the requirements, like say conformance to system requirements, that becomes kind of secondary. As long as the cash is flowing and the PMO seeing progress, people are happy. So there's this consistent theme. There's poor or missing requirements. There's decades of project evidence to show, and this is on a global scale, not just in North America. This is an interesting one where you've got, accountability fade is what we're calling it. It's because these transit and rail projects take 10, 15, 20 years. By the time you're, maybe even 5 or 6 years into a project, the folks that either wrote the original requirements or were, analyzing and trying to implement them, in the first 3 or 4 years may already be gone. They've moved on to greener pastures, and they're kind of looking over their shoulder saying, I don't know, it was pretty good when I left. It seems like it's all gone crazy now. So the accountability feed, that's a real thing because that's how, you don't get the accountability. So and it drives short-term schedule and budget decisions. Because that's the reward structure for the human beings that are making those decisions. They're being rewarded for what's going on right now in this quarter, not something that might appear 15 years or 10 years from now. And the short timeline is the culprit. So this is back over to you, John.
Yeah. So there's a trend that's appearing is that the first 15% of the projects, and we're saying 15%, it could be higher, it could be 20% or so. But, really in this thing, it's getting to say, right, that the startup at the beginning of the project is really, really crucial. How we develop the contract requirements, how we develop the system requirements, things like that. This is starting long, right early, the decisions that are being made and the approaches. Next one down. So Airbus study, this was off the A400M program, 15% of the development cost accounts for 85% of the final system. So they really looked at that. INCOSE, UK's ED3 guide, they've said they did research and they found that 15% of the project timescales had lapsed. 60% of your final costs already committed. And MIT did a study and found that 37% of projects failed to meet any goals objectives due to lack of focus on technical management in the early phases of the project. And so this was from an MIT study in 2000. It's available on the internet, you can look at that. And this is interesting because this really gives you a good split of what was happening. And you can see they looked at 60 projects, and out of that, they said, right, okay, 22 had failed, 11 were sort of in the middle projects, and then 27 projects were really successful. So the 22 projects that failed was interesting, focused on the project management processes. So these are, and we'll discuss this in the next slide, these are doing it. But the 27 projects that were actually very successful and met all their objectives put a lot more emphasis on the technical management processes. And we'll see on the next slide now. So this is good. So ISO 15288 is kind of cut into, you've got the project, the management, which I call the system engineering management side, and then the technical system engineering. So what we're seeing is that, a lot of the stuff here on the management side is very, very similar to everything you see in the PMI. There's a lot of crossover from there, quality management, project planning, portfolio management, things like that. But it's this one on the right-hand side, the technical processes, which, from what from the studies and things, this seems to be driving the success of the project, right? Actually getting in there, analyzing what you're doing, getting the stakeholder needs, doing the design, doing all those elements. It really seems to be the key driver. Now that involves a lot of setup early on. You're getting things that even contractors should be, during the RFP phase, people say, oh, there isn't enough money. They win the project, and then there's a mad rush to try and develop all these processes and plans. So there's got to be some way, and I think we're going to talk about later, about a framework that says, let's think about what you need to target early on in the life cycle and to make this successful. And how do we bring these technical processes into the thinking in project management? So Boeing, this was this was a really lucky kind of study for them, or lucky or fortunate, maybe the better word is, they had three back in, I think it was in 1990, early 90s. They had 3 projects that will all run at the same, all start at the same time with different levels of complexity. And there was a lot of talk about what they wanted to do. And they said, right, okay, we've got project with low complexity, we've got project with fairly medium, project with high complexity. So we're going to deploy some of the system engineering and see how this all works out. Level of system engineering effort versus the schedule is basically what the theme of this one is. Next one. So here they found that the project A that had low system engineering effort, even though it had low effort, actually took nearly 100 weeks to complete. Project B had moderate system engineering. It was a medium-sized complexity, took 49 weeks. But the actual high complexity project, and it had high SE effort, the one they thought that was going to take the most weeks to complete, actually was almost half the time that it took the non-complex one to do. And some of the findings were that Project C was most common, managed to reduce schedule by almost half using SE compared to Project A. Due to complexity faced by Project C, findings showed the SE practice reduced the durations of requirements to contract RFPs, design to implementation, and overall development time. And then obviously this study has formed some of their evidence why they continue to use SE on their projects and programs. So that's a really good one where they, in our problem with rail and transit, we don't have lots of concurrent projects all starting at the same time that we can then measure at the end and say, well, this is it. So they were in a unique position where they were able to measure the progress of that, which is good. And then I think everyone's who's in here, this was done on system engineering return on investment by Honor in 2013, he brought out. And he established that between 12% to 14% of your project FES, if you allocate 12 to 14% of your budget to SE effort, you are getting about 2% cost overrun. If you didn't do any, you're nearly over 50%. 7% seemed to be the average from the study, and they were getting 15%. And then they also looked at, over 20% didn't actually give you any benefit and actually made you over, and that led because, analysis leads to paralysis kind of thing, where you did too much requirements engineering or something along those lines. So, from this perspective, they saw that there's this kind of Goldilocks zone of about 12 to 14% system engineering effort on projects that gives you reduced things. So in summary, what can we do better in the first 15% is we can look at the framework. How is SC embedded in the project management framework? If you look at Network Rail, they have the GRIP process. London Underground have their PMP process, or PMF, I think, when I was there, where that was all embedded into there. Some of that, so those type of things is real good opportunities. Is get SC into your early PM framework. If you have a complex project with a lot of systems in it, then you're going to have to look at your system engineering effort for that. And then, obviously, depending on how complex the project is or how much it costs, you can do it from there. SE techniques and tools that are used in the business planning cycle. Is there any things that you can use that system engineering use to help you aid you in that early business planning cycle? Quality, the contract requirements, con ops, reference concept designs, things like that. That needs to be tracked back and checked with each other and validated to see, is this meeting the con ops? This is how we envisage the operation of the railway. Does our reference design, do our contract requirements actually meet how we want to operate this railway or this transportation system? Gates process, they need to be respected and enforced, certainly in the pre-contract gates, early RFP, and it's just giving a bit more rigor in that area. Just saying, okay, don't be afraid to reject something because you don't feel it's adequately done it. What happens is you get this review, you get a mad rush, you get all the requirements out to contract, you got loads of RFIs that start coming back, and then you proceed, and then there's still deficiencies in the contract as you get further and further down, and disputes and things like that. So maybe the gate process, a little bit more rigorously enforced, pre-RFP, could be a way of improving that quality as well. And then communication, awareness campaigns, can SE do better things to simplify what we're trying to say? We're not expecting everyone to be a requirements guru or understand all the tools we use, but maybe there's a better way we can say how the requirements process can help you, or interface management, things like that, or configuration management. And then also active listening, it also needs the other parties to come and engage. I want to learn what system engineering is doing as well. And I think a lot of people would openly say that it's kind of always appears to be one-way traffic. It's always us having to justify system engineering, rather than people saying, I want to actually know more about system engineering. How can it benefit us? Let's look for the synergies with what we've got already. There you go, Dale, over to you.
Yeah, so once again, the ubiquitous grumpy people staring at you saying, spend the first 15% wisely. Again, that's our key takeaway. We had planned a small intermission, but we're running low on time, so we're going to skip that. And I'm just going to talk about this for 5 minutes because this is like a completely separate prep, and it's really to kind of set the stage for what we're hoping to do in 2020, both with APTA and help from INCOSE and the Rail Industry Group. So both the INCOSE rig and the TWG. We really want to try to get some level of effort completed on this system lifecycle engineering standard, which would come out initially as sort of a best practices guide. And our focus for the first chapters, if you will, is going to be on this early, the early life cycle, just because it makes sense. And you saw sort of a peekaboo version of this slide, but what was different is the key takeaway for this is the intent is to release this initial group of sections in a best practice document in advance of the full document, and see if we can't get some some interest in it. So we would like to start working between the various APTA groups. So for instance, the procurement subcommittee, you know, and I'm not sure if there's a legal subcommittee, but maybe they're together. And project management, you know, we really need to work closely with them. So that's kind of the goal for the next 12 months, is to try to get something happening on this. I'll give you a very quick thumbnail of what we're looking at for deliverables. For maybe we'll just go through a couple of these gates, and then I want to leave a couple of minutes open for questioning or for you to shout at us or whatever. So brainstorming, you know, that's kind of where it all starts, right? You've got some candidate ideas that are maybe coming, and they could be coming from the taxpayers. It could be coming from the governor's office or the president's office or anywhere. And those will help inform and create agency goals. You'll figure what the gaps are. You might start looking at your agency risk register and say, okay, what's, you know, where are our exposures, and how could we deal with that? What are the mega trends? So ITS, you know, the Rail Safety Improvement Act here in North America, that's not a mega trend, that's a law, which is generating things like PTC. And you know, those are some of the things you could do in that early brainstorming and exploratory. So this is like a sub part of the business planning phase. And there's a gate. So you have to go through the gate. So these would be the ideas, these would be the deliverables for the gate. And then you start reducing all of the ideas that come out of the brainstorming session. So you've got, you know, you update the risk register and that sort of thing. And then you actually get to the point where you're putting a business case together. So you get a conceptual level business case where you've got a stakeholder engagement plan. You've maybe got an initial ConOps. You start thinking about a project charter. You start thinking about the public strategy and the marketing plan for, you know, if it's like a group of new infill stations or a new line or maybe bus rapid transit, whatever it is you're thinking about doing for your agency. And obviously cost analysis, and again, constantly updating the risk register. So that would be the first of the 4 main phases, the business planning phase, which would then launch you into the project planning phase. So out of the business planning phase, you know, you've gone to the gate here, the gate being could be anybody, but whoever's in authority to say yay or nay to a project or a candidate project, I should say. You go, you know, so that might be a board of directors meeting, and you end up with your idea on the capital budget or the capital planning sheet. And then it, you know, so it's starting to get real now. It's, you know, you're into project planning phase. So you start putting together an actual project management plan, maybe refine the charter. You know, again, there's some sub gates in here, so you don't get to go rushing right ahead and do things without, you know, sort of an incremental spend approach, which is an incremental risk mitigation approach, basically. So that's kind of what we're looking at, and providing a lot of this information in the best practices guide. So there's a ton of work to do in 2022. I won't go through the rest of these because we're actually going to generate some requirements, and we've got some interesting ideas for early supplier engagement and competitive bidding that includes design competitions and that sort of thing. So we will leave all that for another time and just open it up for questions.
Well, there are a few questions in the chat.
Okay, thanks, Hokie.
Yeah, there are comments actually.
Okay, I can't see the chat here. Let me stop sharing for a second, then I can see all this stuff. Stop share. And yeah, we're still recording, right? So yeah, let's go for it in the chat. Open up the chat here. Okay, observations for failure. This is from Marcel. Requirements for fixed scope with finish, which is way too far ahead, too far in the future. Too much is insecure. Clients want to capture the requirements. Other observational lack of systematic approach of stakeholders to capture the requirements. Yes, I agree. Marcel, did you want to talk about that for a minute or two? I guess we've only got 3 minutes left, but we'll open the floor up here.
One of the latter observation, lack of systematic approach. Too often you see that stakeholders are gathered together and they get a lot of sticky notes and let them write their requirements down. That's not a systematic approach. And way too often that happens.
Yeah. Yep. Excellent. Yep. Totally agree. Carlos.
And the other one is,
Well, yep.
and the other one is just capturing the future, and that's not possible. If you have a project that has a lead time of 10 years, how can you ever think of what's happening in 10 years from now? And they still want to capture those requirements, and that's impossible.
Yeah, it's pretty tough to crystal ball some of the, especially with the rate of change of technology. Yeah.
So, Milestones, to answer one of your questions about stakeholders, I think when you're looking at stakeholder requirements, certainly something, if you look at the object management, OOSCM, and kind of model-based system engineering, they lean towards more about stakeholder concerns. Really sitting down with them and say, well, what are you really concerned about here, with the project? And then that leads to then obviously doing artifacts and everything further down to actually start addressing those concerns. And then you can actually look at, okay, what's that? Their concern is we might not meet the ridership, and things like that. And it's a slightly different way to like saying, can you go and give me all your gold-plated ideas and we'll figure out which ones we can deliver or not. And so it's almost kind of driving out saying, well, we've captured all your concerns here, right? This is how we think we're going to be able to deliver it. This is the type of contract that we want you to do. Obviously when you add in the performance, if you're looking at a certain amount of trains per hour, which the whole business case may be set on, things like that, they may have a concern that we don't think you're going to meet your trains per hour, but our business case is based on that. What would be the requirements and things downstream and the mitigations to ensure that you're trying to track that. So that's a kind of another thing that's sort of coming from model-based system engineering, where they're really homing in on the stakeholder concerns and then jiving out the requirements from there.
Yep. Thanks, John. I guess we're actually at time, so we'll try to respect everybody's time. And sorry, we probably left not enough time at the end, but we're going to keep this is kind of be our theme. I'm hoping for a great number of these discussions going into 2022. So we welcome people to contact us, and if you're interested in helping us work on the documents, the actual deliverables, because I mean, that's what engineers like to do, is create things as opposed to just listening to PowerPoints. So we'll try to rope some of you into either reviewing and or authoring and reviewing. So that'll be fantastic. And really just I'll turn it back to Mike and Hokie, but I just want to wish everybody a safe and good holiday season. We're getting to that point now, and look forward to a great 2022. And if you get a chance, take a look at the IW website. I guess it's still a hybrid event at the end of January. So we'll hope that happens. And but it's hard to tell in this age of COVID. So yeah, best wishes everybody, and take it over, Mike. I'll stop recording now.
Okay, well, thank you very much, Dale and John. Round of applause.